Okay, this is a lesson on angles and radian measure. Remember to follow the directions, especially with questions 42 through 56 even section on the assignment. Okay, an angle is formed when two rays have a common endpoint. So the standard position where one ray lays along the x-axis extended out like this. Oops, sorry, there we go. Where it goes this way. And the other one toward the right, that would be a standard angle. So if it just basically goes like that's a standard position going this way. Now positive angles measure in a counterclockwise rotation, so it would move around and stop at some point, kind of maybe there. Okay, that would be a positive measure. Negative angles start in the same position, but they go the other direction. So they would go this way, kind of like that. Okay, so the first thing you need to know is what a radian is. A radian is simply measuring a distance around the outside of the circle. So the distance for the radius is this long. So if you wrapped that around the outside of the circle, you would get about 3.5 of those, or 3.14. That's or sorry, 6.5 of those, or 3.14 in half a circle. Now, what you can do in this formula is take the radius and try to define a central angle. Now, a central angle in this example goes from here to here. It's just an angle that rotates around the center of a circle. Now, that's theta. So if I want to find what that angle is in radian, all I have to do is take the arc measurement. So if I just took a little tape measure and I measured all the way from there to there, and then I divided it by the length of the radius, which would be from here to here. So in a circle radius of 12 feet, that's 12, and an arc length of 42 feet, what is the radian measure? Well, you just take 42 divided by 12, and you get 3.5 radians. Okay, so remember, before I said that there are 6.28 radians in a whole circle. So if there's 6.28 in the whole circle, and here is 3.14, this is just a little bit beyond that to 3.5 radians. Again, a radian is this long. So 1, 2, 3.5. Okay, angle measure. Now you're probably familiar with measuring angles in degrees, but now we're going to also start measuring angles in radians. Now I just mentioned that a full circle is 6.28 radians approximately. That can also be written as 2 pi, or half circle is 3.14 radians. That's the same as pi, or a right angle is half of that, pi over 2. Now that is the same as a full circle being the same as 360, half circle 180, and right angle 90. This is just a page that talks about radians again and the circumference of the circle formula being 2 pi r, just a reminder. Converting. If you want to convert from angles to degrees or degrees to, from radians to degrees and then, or back again from degrees to radians, I have a couple of examples here how to do that. I think it would be best just to show you how I would do that. For number 2a, if you want to take 30 degrees, you would have to multiply by 180 degrees on the bottom and then pi radians on the top. This fraction represents the number 1 because pi radians is exactly the same as 180 degrees. If you took that away, you'd still have the same measure. Multiplying it still gives you the same measure, it's just that we're converting it to a different unit. So you'll notice that when we have the degrees on the top and the degrees on the bottom, those are going to cancel. And then I'd have 30 pi over 180 radians. That's the only unit left. And then if I reduce that, that's pi over 6 radians. 270, same thing. 270 degrees. Multiply that by pi radians over 180 degrees. Degrees will cancel, and 270 pi over 180 reduces down to 3 pi over 2 radians. And this one, I'm not going to write it all out. This one gets you negative 5 pi over 3. Now if you go back, this is the number of radians, right? So I would have to multiply by the unit conversion fraction upside down. So that would be 180 degrees over pi radians. So notice that the radian units cancel and the pi units cancel. So I just get 180 divided by 4 degrees. So that would be 45 degrees. And you can write the degrees as just a little 0. Same thing here. I'm going to move the negative up to the 4 before I start converting. This is the number of radians. And then I'm going to multiply again by 180 degrees over pi radians. Okay, the radian units cancel, the pi's cancel. Negative 4 times 180 is negative 720, and then 3 is what I've got on the bottom. That's how many degrees we have. So my answer is negative 240 degrees. Now the last example was just to show you that radians don't have to have a pi in them. They could just be 6. And if you multiplied 6 by 180 over pi, we could get a decimal answer. It would be 343.77 degrees if I rounded it off to 2 places. All right. Now, it is very important that you understand how to measure angles and know exactly where these are in radians. So, I'll widen this out a little bit. So, if you want to find pi over 2, you basically just have to know where pi is. Pi is half a circle. So basically, if you started rotating here and rotated it all the way over there, pi over 2 would be halfway. So that, rotating to there, is a pi over 2. Remember, negative goes the other way. We start in the same position, but we rotate down. So that would be negative pi over 2. And all the way over to here would be negative pi if we kept rotating that way. Positive pi over 4, well, let's see. If this is pi, that's 4/4 pi. So halfway would be 2/4 pi. So half of that would be 1/4 pi. So this is pi over 4. That would be 3 pi over 4 if you're curious. So if that is pi over 4 going up this way, then what's negative pi over 4? Well, if you go this way and then rotate that same distance down, half of a half circle, that would be negative pi over 4. So, what does pi over 3 look like? Well, remember, this is pi. Starting here, rotating over to there. You could also call that 3/3 pi. So if you cut this half circle into thirds, this would be 1/3 pi, and that would be 2/3 pi, and that would give you 3/3 pi. So this is my angle for pi over 3. If you rotate that same distance downward, that's negative pi over 3. Pi over 6 is a 1/6 of a half circle, so this would be 6 pi over 6. This would be 3 pi over 6. And then if I divide this into 3 pieces, I'd get pi over 6 and 2 pi over 6. So this tiny little angle right there would be pi over 6. If you rotate it in the opposite direction, that short distance, that would be negative pi over 6.